All right, I think we are live.
Great.
So we are gonna get started on this side and just wait for everybody to come in because I know a lot of people are just, it's still going in, people are still joining. Different parts of the world, different times in different time zones for sure. Because,
Yeah,
I
yeah.
know you are in Singapore and right now I'm on
You're
the
not
other side of
exactly
the
in my
world.
time zone.
Not
Exactly,
in your time
exactly.
zone for sure.
I think you're about the furthest away that you can get
Yeah,
from Central.
I wanted to make sure, why not? Let's see if we could stretch it across the globe.
Yeah, exactly. It's really a global event.
Why not? It's always global. Always,
Yeah.
always global. So I'm going to introduce you to Lars. Lars is the general manager over at Fluidtech, and he does an amazing job in the APAC region. Like, I've had the pleasure of working with him in that region, and it's very interesting. We have so many different cultures, so I always love that part about it. And Lars is actually going to tell us a little bit more about advancing your machines to Fill4Life Systems. And this is something that is always very interesting because we're always thinking, what is the next step forward? How do we, make all of these different systems that we have? We want them to last forever because these systems are not cheap. We want to make sure that it can last for a long time because we've invested quite a lot in it. So I know Lars has something very nice lined up for us today, and he will be giving us more information on that. So Lars, I'm going to pass it over to you in your very capable hands, and
Thank
we're
you.
going to start.
Thank you very much, Sanya, for that lovely introduction.
Most
Always a
welcome.
pleasure to work with you. Hope it's not too late on your side. So today I have the honor of speaking to the audience about advancing your machine to Fill4Life Systems. Important topic, as Sonia said, because we all operate advanced and expensive equipment. Of course, we want them to last as long as possible. So today I will talk to you about a few topics. The introduction is done very lovely by Sonia, so thanks for that. We'll talk a little bit about turbine oils. What are they supposed to do and how do they fail? It's a bit of a high level overview on things. And at the end, I want you to walk away with new ideas and new methods on how to make your equipment last as long as possible. And also, very important, how to make them run as efficiently as possible and how you can save some money, some time, but also save or at least help save the planet. So, this is a strange combination. We say we are greening the lubricant industry. That may sound strange, but what's not very commonly known among the public is that lubricants play a vital role in reducing friction. And if you reduce friction, you increase the energy efficiency. So you reduce the energy usage, which means you reduce the CO2. So lubricants are actually a crucial part in sustainability. They are everywhere as well, they are unavoidable. So when we zoom in a little bit on industrial lubricants, we are faced with the fact that this is currently a very antiquated model. What this means is the industrial lubricant space is driven by consumables. It's all about pumping around this volume, getting the oil into equipment as many times as possible, changing the oil as many times as possible. That's the driving force behind this industry. It's one of the biggest markets in the world, and it's making a lot of money. But it's also producing a lot of CO2, and it's not a very efficient model at the moment. So when we look at the life cycle assessment, that means the pollution of a lubricant throughout its life cycle, we actually can identify something very interesting. You see all these big refineries, big plants, oil exploration platforms, and so on. And we all know these are very polluting, right? But when we look at the total life cycle of a lubricant, this part, the cradle to gate, the production and logistic, the flying it around the world part, basically, or shipping it around the world, I should say mostly, is actually only 33% of the total pollution that a lubricant generates over its lifetime. The majority of the pollution is at the end of a lubricant's life. So why is that? That's because only 50% of lubricants that are used are recycled in today's world. The rest basically gets burnt up into the atmosphere. With all the chemistry and molecules that are inside, you can imagine this generates a lot of pollution and a lot of CO2. And this is no longer necessary. At least we can reduce this quite a bit because the technology exists today to go from the current model where we use up a lubricant and then dispose it to a model that's much more efficient, which we call the Fill4Life model. This consists of a cycle of activities that users and operators can do to get more out of their lubricants. That means extending the life of their lubes. That means lower operational cost, less risk, less maintenance, less time, higher profits, less pollution. The lubricants last longer, the end of life pollution goes down, and it's a win-win for everybody. So there's a certain cycle of activities that the end user can do, which ranges from starting with being predictive instead of reactive. That's very important, meaning we want to do the right tests, we want to generate the right data on the fluids to make sure we have an accurate picture of their condition. We want to use everything at our disposal, both online and offline, relationship with OEMs, relationships with lubricant suppliers, to get all the information that we need to come up with a proper consultation for the customer. And then at the end, we also want to treat, of course. And this is where it becomes interesting, and I'll go a little bit more deeper into that later on in the presentation. But when we look at the product categories that we can provide, we can identify four main categories. And the interesting one that I want to zoom in a little bit more today at the end of this presentation is the last one, which is life extension. So this is, of course, important when we look at the end of life cycle. We can extend the life of the lubricant, means we reduce the CO2 and reduce the environmental impact. The product lines that we provide at the customer side range from different filtration methods to aftermarket additions to the oil, which contain additives or can enhance solubility of the oils, which I'll explain a little bit more deeper. These product lines are always growing. A lot of R&D is being invested into them. They are innovative, new technologies to extend the life of lubricants, but also to optimize lubrication during its lifetime. These solutions are innovative, but they're not that new. They've been actually around for a while, and they are supported by the industry. That means the OEMs are supporting these technologies. They are recommending it to their customers. Even the oil suppliers support these technologies. And you would say, why would they support something that decreases their profit, that makes them sell less? Well, they are also very interested in reducing operational cost, and they're also very interested in showing that they are sustainable. So that's how the oil suppliers are also engaging with this technology. So here you can see an example of industry support letters. And for example, one of the oil majors is also actively promoting their operational savings. As you can see in this case in the refinery, some significant savings. They are promoting this online, which is due to our technologies called, in this case, the Solvencer and Decon product range, which has been applied to achieve this cost saving. So when we look at modern turbine oils, we need to zoom in a little bit on this because we need to start with the basics. We need to understand what's going on with the fluid. So when we look at a modern turbine oil, we needed to do two main things. Everything in the world oxidizes. Even our bodies undergo oxidation. So an oil needs to resist oxidation. It has a slate of antioxidants inside to combat the environmental conditions or the operating conditions. We also want it to control deposits, because when it starts to decompose, it starts to form what we call degradation byproducts, which deposits into the internals of your equipment. And of course, that will cause a lot of operational issues. So this is what we want the oil to do. But of course, there are ways in which an oil's performance gets degraded. So this is what we call failure modes. The primary failure modes of turbines can cause the operators a lot of headache. And this is what we want to prevent, because you can imagine if you have bearing failures, if you have sticking valves that are interfering with your startup time or interfering with your overall efficiency, this will greatly diminish your operational efficiency and will decrease your profit. It will make your plant less profitable. So this is what we want to prevent. And additive depletion, the last part here, is a very important aspect to consider because additives are sacrificial. They are consumed over time. And once they are consumed, the oil will degrade very rapidly. Luckily, there are various solutions to the operators that we can provide. So the newest solution that we have here is re-additization of the oil, which is called Decon AO. AO here stands for antioxidants. We can also apply advanced filtration methods to keep the oil running clean and in a good state, because that's very important. That's what it's all about. We want the oil to run clean and pure with the correct amount of additives. As long as we do that, we can avoid these nasty failure modes here. Now let's talk about monsters. Let's look at this varnish monster here. I hope you've never seen this in real life. It's a nice AI-generated image that we have here of a varnished turbine oil. So let's look at what this means and deposits in your system, which we can also consider to be the cholesterol of machines. As human beings, we are concerned with cholesterol because it clogs up our system. It allows our heart to be exposed to a lot of potential issues, right? It can prevent blood from being pumped around and so on. So in the industrial world, we see varnish as the cholesterol of machines because it can interfere with a lot of things. So I'll show you some examples here. When you have a high cholesterol system or a highly varnished system, the first thing you'll notice, and the primary thing that we see, is valves that no longer work properly, which will increase your startup time, and it will decrease your efficiency. Also on your bearings, which are very high-speed rotational equipment, you will see instabilities. You will start to see vibrations. You will start to see temperature changes, temperature excursions, and so on. The lubricant in many cases also acts as a seal. So when there are deposits inside, it can no longer perform its job. Then you might get gas ingression in your system. Gas and lubricants typically don't go well together, so this interferes with the operation of your system, leading to failure. When your heat exchangers are exposed to deposits, it means they reduce in efficiency, and that means they can no longer cool down or heat up your system as efficiently as they used to, further degrading the profitability and efficiency and environmental friendliness of your plant. So keeping your system clean and preventing this from happening is very important. But what is this phenomena? So we define varnish a little more broadly to be an oil-derived deposit. That means it's not an external contaminant. It's coming from the oil itself. It's depleted additives. It's degraded base oil molecules, degraded hydrocarbons. So it's coming from inside the oil itself, accumulating and then depositing out of solution to the oil. So this makes it also a bit tricky to handle. Because it's coming from the oil itself, it has a certain aspect that makes it impossible to filter it out. What we see here is an oil that clearly has an issue. It's clearly varnished, it has a contamination inside. But when we add turbulence and we add temperature, which is exactly the same thing that would happen in industrial equipment, right? Because there was always turbulence on the oil and there's temperature because of the operating conditions. We see that the contaminants dissolve completely into the oil. Now, in this state, when your machine is running under operating conditions, there is no way to filter out these contaminants. They will stay in your system. So even if you have a 1 micron depth media filtration system, the contaminants in this condition will pass right through your filter mechanisms and will cause a lot of issues in your system. So this is what we want to prevent. And for this, we have devised special methods to take out or to neutralize the contaminants when they are in this state. So during operation of your equipment. And that's crucial. What we also see as a result of varnish is increasing in bearing wear rates, what I called earlier bearing instability. These are very high speed, very critical parts of the equipment that are operating with very low tolerances, and the lubricant performs a very crucial role in this part of any industrial equipment, basically. But I'll show you some examples which are mainly coming from turbines and the bigger bearing systems that we have in turbines. So here you can see some results when we have deposits and varnish in your system and how they increase the wear rate. So here you can see thermal damage and the varnish acting as an insulator and degrading the oil at this particular point, and this will of course lead to bearing failure. Here we see a very interesting picture where the oil wedge has been disrupted and the oil film is disrupted, which leads to metal contact, which leads to what's called micropitting, chipping away of the metal over time, which increases, of course, the wear metals in your oil, which further degrades the system. But in this area here, you will have also bearing instability and bearing failure. Here we see some other examples of thermal damage as well. And on the truss bearings, on the truss pads, you will see on the bearing pads here, you will see where thermal damage has also interfered with the oil's ability to form a strong oil film. And in the hydrodynamic regime, there should not be any micropitting, but in this case, there has been micropitting, leading to, of course, the failure of the bearing in the end. Now, when we zoom in on temperature, we have to consider that the deposit layer that you see here on these pictures will act as an insulator. This means one of the key aspects of an oil is to cool down your machine. It's designed to dissipate heat, to transport heat away from the critical areas of your equipment. Now, when there is a deposit layer, which is an insulator, it becomes more difficult for the oil to do this. So the oil's ability to cool down your system is diminished and there's an interference. Now, what we see when we look at the temperature excursions, we see a very interesting pattern, which also gives us a very good way of determining what is the issue. Because the varnish and deposit layer will constantly change in thickness. So it accumulates to a certain level, then there is pressure in the bearing system, which shaves off part of the deposits, which means they reduce again, and then the temperature goes down again. So this is an ongoing battle between the deposits, between the pressure in the system and the oil itself that will go on, and that will increase and decrease the temperature over a period of time. Now, once the accumulation of deposit gets worse, you'll see this increase in amplitude, and over time, you'll get into an issue. So we can detect it early when we see this, what's called a sawtooth pattern of temperature increases. Sometimes it does not ring an alarm bell because the average temperature of the bearing system is not going up that much. But we need to monitor these temperature spikes, because at these temperature spikes, that's where the oil degrades even more, because oil does not do so well at elevated temperatures. So it starts to decompose at exactly these spots into the bearing, and it starts to deposit more on your bearings. So when we see the sawtooth pattern, we know for 99% sure that you have a deposit or varnish issue. So we have zoomed in a little bit on the symptoms, but now let's look a little bit at, the culprit in a way, but let's look at how do oils degrade. So we have devised a test that's called accelerated turbine oil aging. So I won't go too much into the details, but it's a test that is designed to simulate in a number of weeks the lifetime of the oil. So here you can see 3, 6, 9, and 12 weeks, where we take a sample of out of the test to do some oil analysis test on. This stands for 3 years, 6 years, 9 years, and 12 years. So in this way, we can very accurately predict in 12 weeks of testing how a turbine oil will behave throughout a lifetime of 12 years. So it's a very valuable test, and it's mainly focusing on oxidation and deposits, because remember, these are the primary failure modes of turbine oils. Now, when we look at the visual glassware, when we look at these results, you can already see a very interesting pattern, right? Because these are all officially approved turbine oils, right? Unfortunately, I will not share names with you today. We want to keep the oil suppliers as our friends, but 21 oils here that have very different performances. So if you are a user of oil number 19, 20, or 21, you'll have a very different experience from oils 1 to 3. But both of them are completely approved for use. So you're free to buy within even your warranty period these oils for most of your OEMs. So that's very interesting. The freedom of choice is there for end users, of course. Also, availability of certain oils is very different in different regions. Different markets have different oils available. Pricing and so on all play a factor. So that's why there's a wide variety of oils available to end users. But the performances are very different. So let's zoom in on an example. Here we see a formulation that was using a sulfurized EP additive to boost the oil's performance under gear loading, and that means it means that it's a multifunctional oil. However, the sulfurized EP in this case was leading to oxidation and to deposits. So immediately the oil collapsed under the conditions that we subjected it to. It was not a suitable additive for these conditions, and we can see immediately the additive system of the oil collapsing. And we can see the NPC test, which is a test to detect deposits and varnish in the oil. We see this shooting up to critical levels. So this oil basically collapsed immediately and would give enormous problems if you would subject it to these conditions in your turbine or in the field. Now, when we zoom into the oil that has the largest market share at the moment, we can see that the MPC test here is a very good predictor for deposit. You can see a correlation between the visual deposits and the MPC test. And we can conclude that this oil is not the best performing oil, but it has a very predictable degradation pattern. So that means it is not likely to cause severe issues immediately, but it can, when the end user would do correct condition monitoring and monitor all these parameters, they will have some time to act on this oil, and they can apply some of our solutions, for example, to prevent this from happening and to make sure that this oil lasts much longer than it does in this test. Unfortunately, oil testing does not always give you a good indication. That makes it a little more challenging for the end users, as if it wasn't challenging enough. But here you can see the MPC is staying low, and the visual deposits are still increasing. So also the additive systems are good. So unfortunately, in this particular formulation, we see that the MPC and the oil test do not necessarily indicate a problem, but here we are forced to rely on visual inspections to know when there is an issue. So the conclusion here is a lot of different oils on the market, a lot of different experiences by end users, a lot of different performances. But how can we equalize the playing field? Can we provide a solution to the end user that will make life easier for them? So fortunately we can. We have developed a product that's called Decon, which can be used as a problem solver, but generally speaking, it's a very good proactive way to manage this problem. So how can we do that? I'm going to show you another test slate. So here we see the new oil, which has been stressed in this test. Immediately, the MPC goes critical. So this is actually a very bad performing oil. You can see a lot of varnish and deposits inside. When we do the same oil in the same test, but then we add 3% of Decon before we do the test, so we use it as a preventive measurement, then we see that the MPC doesn't go to this critical level. It doesn't even go much higher than the new oil. So that means that our solubility enhancer, our Decon, is providing protection against deposits and varnish. So even in a bad performing oil, we see that with this solution, you don't have to worry about deposits and varnish anymore. And the rest of the oil parameters are not affected. So that's a very good thing because you don't want to affect negatively the oil, right? So we've done the TOPP test as well with Decon, and we see very similar results here. When we go to week 12, MPC is low, no visual deposits, and a nice gradual degradation pattern of the additives, which means the oil inside would be very, very predictable. And this offers us a lot of opportunity to look at what we can do with these antioxidants to boost them, perhaps, to make the oil last even longer. But let's zoom in a little bit more on this oil because the additives at the end of this test have been mostly depleted. But we decided to continue the test and to let it run for 18 weeks. So that means that even after the additives are depleted, in this case a simulated time of 18 years, the Decon product inside the oil still prevents deposits from forming. So this gives end users an additional protection, an additional peace of mind against the formation of deposits. So even when your oil is completely shut, the additives are gone, still our product can protect against deposits and varnish. It's simple and risk-free to use, treat rates of 3 to 5%, and it's fully compatible, which is very important with all the industrial oils that are, and not all, but group 1 to 4 industrial oils that are currently in the market. So that's the bulk of it. No risk in compatibility there. We can show this versus some competition. When we compare our product versus competitors that are claiming to remove varnish from the oil as well, we can see a distinct difference because there is no other product that is suitable for long-term use in oil that gives the same results as Decon. When we compare these results, we can clearly see that the products that are used in the market as competition cannot be used in the oil for a longer period of time. They cannot be used during the operation of the machine. They can be used as a pre-cleaner, but because they are usually detergent-based, they do not interact well with the oil. Detergents and lubricants do not go well together for longer periods of time. So Decon is the only product in the market today that gives you a carefree life for longer periods of time. It's completely suitable to extend the life of your oil without any risks of compatibility. So here we can see the benefits. To summarize it, it's at the moment the only solubility enhancer product in the market that is tailored for oil use. It's an oil-soluble cleaner that you can use to clean your system before an oil change of deposits and varnish, but it's a unique product because it's the only product in the market that can be used throughout the oil's lifetime without any concern. And I would like to highlight that on this part. It's the only solubility enhancing technology that can provide you a short-term solution, but also long-term protection against varnish and deposits. We love teamwork at FluidTech. I hope you do too. So we also have our specialized filtration systems, which I mentioned in the beginning. And these are able to take out contaminants, oil-soluble contaminants from the oil during operation conditions. Remember the solubility aspect that I showed you earlier, where the contaminants get dissolved into the oil in operating conditions? Well, we use an ion exchange-based technology, which interacts with the molecules of the varnish and deposits, the degradation molecules, as we call it. It attracts them into the resin beads and keeps them there and neutralizes these molecules. So this is a specialized technology. It's not a regular depth media filter. It's something very differently. And we have devised different technologies, different sizes with their own kidney loop system. And there's a new kid on the block here, which is an inline system, which uses the same resin technology, but does not need its own power source. It can be engineered as an inline filter in turbine oil systems. And when we combine this technology with the aforementioned Decon, we have the perfect solution because we prevent the buildup of varnish through Decon. We solubilize the contaminants, but we also take them out of your system through this ESP technology. And especially when we combine this with antioxidants and antioxidants boosting, we can extend the life of the antioxidants because we will remove all the bad stuff from your oil, which will attack your antioxidant system. So by keeping the oil clean, we extend its life even further. Now we talk a little bit about antioxidants. That brings me to the next topic, which is one of the most important parts about advancing your systems to a Fill4Life system. We need to look at your additives. The additive system of the oil is what's giving the oil its performance. It's in many ways the performance enhancer of your oil. Now let's look a little bit at the general turbine oil formulation, and this actually applies to a lot of industrial oils as well. So what is interesting here is that 91% minimum, but in reality, this is not always used. So in many cases, it's 99% of the oil that you're using is actually refined oil, base oil. It's not a technologically advanced product. It's coming straight from the refinery. And what the oil producer does, they are adding 1%, typically in turbine oils, of antioxidants, which are typical aminic and phenolic antioxidant packages which are designed to resist the antioxidants, to resist oxidation, sorry. And this is what's giving the oil its performance. However, we also say when the performance of the oil goes down to 25% of new, you have to change the oil. So if this 1% is giving it its performance, then when this goes to 0.25%, we have to change the oil. What this means is you're throwing away 99% of base oil, which, because it has not been depleted yet, it is not attacked yet. It means it's in a good condition. In many cases, it's in a very good condition. So then we throw out 99% of all this good stuff that we could still use. So instead of doing that, when the base oil is still in a good condition, and we can determine that by doing oil analysis, instead of that, let's just replenish the part of the oil that gives the oil the performance. Why not? This sounds totally logical. So instead of throwing out all this base oil and putting new, we're just going to focus on this 1% and replenish that. In order to achieve this safely, we would always do upfront testing. That means we want to guarantee at the end user level that the oil will perform after we treat it and that there's no compatibility risk. And here you can see already some nice results when we do the pre-test. You can see that the particle count after dosing it with Decon goes down because Decon is a solubility enhancer, so it dissolves all these particles back into the oil. And here we can see oxidation performance, RPVOT, from 30, which is almost nothing, very bad condition of the oil, up to 960, which is close to the new oil. We see the same results when we measure for the actual antioxidant levels through the ruler test. We see that it increases to above 100% aminic, which is giving the oil most performance. And the MPC, the varnish potential, is going down to 14.5. So we're killing a lot of birds here with one stone. We go from an oil that was supposed to be discarded to an oil that's basically at the same performance level as a new oil. So we're not just doing testing, we can also prove this by various case studies. So I'm going to show you today the oldest case study because that probably holds the most value when we determine whether this is something we can do. The oldest case study for us is in the US with Mesquite Power. There's also a YouTube video available where the supervisor will explain a little bit more about what they have done and how they have managed to achieve very nice results with our products. So in summary, what this company has achieved is $3.5 million of US dollar savings and also 3,000 tons of CO2 saved from being expelled into the environment. So excellent results. But how did they do that? They did that by condition monitoring, keeping track of their antioxidant level, because that's where it always starts with. We need to keep track, we need to measure. You can't fix what you don't measure. So when the antioxidant levels deplete, in this case we are at 60%, we decided to add Decon AO to this product, to this oil. So our products go in, then we see the additive level going to close to 190%. So almost double the amount of performance compared to new oil. Then this oil shows a very nice gradual degradation pattern, no issues, no varnish, no deposits at all. In 2022, we went below 100%, and the user told us, why not do it again? So in 2023, we decided to increase another dosage of Decon AO, and we again brought the additive level back to the level we did 10 years ago. So we have some very nice data points here in 2012 and 2023. And what we can conclude is that we have a turbine oil here that was 8 years old when we started treating it. It was initially extended to 10 years, by 10 years, sorry. So that means it's 18 years old. However, it's still in excellent condition. So remember, all this base oil that's in the system is not degraded. It's in an excellent condition. So we can easily extend this for another 10 years, and then we go to 28 years. So this means they save another $3.5 million. So at this point in time, at this point in time, they have saved $3.5 million over the last 10 years, but they're going to save another $3.5 million over the coming 10 years. We calculate this, we do this together with the customer, as you can see here. We can calculate CO2 savings. We can calculate how much money has been saved, all validated by the customer. And in the future, this is important. This can be used for carbon accounting as well. This allows our customers to show how much CO2 they are saving and what efforts they do to reduce CO2, which can have additional financial benefits because many countries have moved to taxing CO2 emissions. So if you can reduce your CO2 emission, you have further profits to enjoy. So to summarize this case study here, this is an example of just 1 out of 6 units. So we have similar results with 6 units. And as mentioned, what we will end up with here is a turbine oil that will last at least, maybe even more, but that will last at least 30 years in the system. Now, remember, this is a large frame gas turbine. This is a massive GE turbine, power generation turbine, with a lot of heat, a lot of internal combustion taking place. It's a very stringent environment. It's unheard of to have 30 years of life in such an environment. We have oils that last 30 years on hydrodynamic turbines, for example, because they have much lower temperatures. But in a large frame gas turbine, it's completely unheard of to have a turbine oil that lasts 30 years. So without doing bleed and feed or top up, by the way, this is just this oil gets only treated with Decon AO throughout this life cycle. So what we can conclude then is that additive replenishment is nowadays a proven methodology to extend the turbine oil, the life of the turbine oil, and that means we are well on our way to a Fill4Life turbine oil. And to prove this concept, that we can say, no longer throw out your oil. Don't waste this much money. Don't put so much stress on the environment. Let's extend your oil life. Keep using it. Reduce your flushing. Reduce your maintenance. Reduce your overall cost of operation, and save a lot of money in the process as well. So for Asia, we also have some local case studies available. So I'm just going to go through some of the primary ones. We have done something similar with ExxonMobil in Singapore, where we've used Decon AO as additive boosting to extend the life of the oil. Same result. Also, this customer on just one equipment will be able to save close to $500,000 over a period of 10 years. So similar results than what we see in the US, and we are seeing this globally now. Also in the offshore world, in offshore industries, the power generation turbines that they're using are very critical. They are operating in a critical environment where usually they don't like to have electrical components such as kidney loop filters at the site. So they really welcome a fluid addition that they can add to their system to further extend the life of the oil. But more importantly, they don't want to have a shutdown. They don't want to do an oil change. They don't want to flush their system. They're doing it only because it's strictly necessary. So when we give them an alternative, Decon AO, for life extension, it saves them a lot of time, it saves them a lot of money, and it reduces risk to their operations, and it reduces risk to their system. So they can sleep better at night and they have less shutdown time. Same for CNO Yacheng, the Chinese operator, where we have used both filtration system plus Decon AO as the ideal case for life extension. Remember, when we combine ESP filtration plus Decon AO, we get the maximum results because we continuously remove the bad stuff from the oil. Also in Singapore, Keppel Merlimau. Keppel is a big supporting group, various OEMs, GE, MHI, and so on. They are Mitsubishi Heavy Industries, that is. They are using our products in various equipments, and we see a continuous reduction of MPC and a normal oil condition. So going from oils that they had to change to oils that they can continue to use. And again, decent savings over a period of time. Also in pharmaceuticals, very advanced manufacturing, we are in there now as well. Similar, very good results, preventing an oil change. Keeping the acidity low is also a result that we often see, which is very important to extend the life of your oil. Last but not least, the largest power plant in Singapore is also continuously using our products. So very satisfied, also on different OEMs, and we'll continue to extend the life of the oil. So overall, we've saved a lot of money just in Singapore alone, and a lot of oil from being prematurely discarded into the environment. So I'm going to finish the presentation now, and I'm going to answer some questions. But before I leave, I want to bring back attention to this part. The the general model of Fill4Life is now used mostly on turbine oils and bigger compressor oils, for example, because these are large oil sums and the operator has a lot of benefits by doing this continuous cycle of activities to help them save oil and to be more energy efficient. But this process is applicable to all, or at least most, industrial oils and applications. So even if you're operating a turbine oil, if you're operating a gear oil, if you're operating a smaller system, a bigger system, have a look at this concept because it can save you a lot of money, it can save you a lot of waste, and it can help save the environment. So it's a win-win for everybody. So please have a look at this Fill4Life to advance your equipment to Fill4Life systems. So that leaves me to thank the audience for your attention. I hope you learned something today, and feel free to contact us for any more information. And I'll be happy to answer some questions from the audience. Thank you very much.
Thank you so much, Lars. Like that was a great presentation. I know we have Irma Lisa saying, that was a really good session. Thank you so much for sharing and for letting us know so much information about the Fill for Life system. I
Thank
think
you.
one of my biggest takeaways from this is that we have all of this base oil in our turbine systems, and a lot of time it goes to waste, and that is not good for the environment. Clearly
Exactly.
not. And if there are ways that we can, try and make it a little bit better, a little bit easier on the environment. I love the fact that, there are certain things that we can do to get those carbon credits because, those are going to be taken in effect very, very soon.
Yeah.
So I like that you shared that for us.
Mm-hmm.
So we don't have any questions right now,
Mm-hmm. All
but
right.
I'm just gonna give you my thoughts on what we have so far
All right.
in terms of being able to bring that value to the
Mm-hmm.
customers, to be able to tell them, okay, well, you don't have to throw away this amount of oil
Mm-hmm.
because it costs money to dispose, it costs money to replace, it costs money to do all of these other things when
Mm-hmm.
you
No
can
fair
just,
question.
make it a little bit better.
Yeah. Yeah. Absolutely. Absolutely. So it's all about a
So
win-win
that,
situation, right? I think that's the
yeah,
most important part. The end user wins by saving money, saving cost on what you say disposal, but also flushing
yeah,
costs. They reduce their downtime, which means they can produce more. They can produce more efficiently, so their CO2 per unit and their cost per unit goes down as well. So that's a lot of benefit. And at the same time, they can help save the environment. They can reduce their CO2. So it's a win-win. And for the oil suppliers, it's the same thing. They reduce their operational costs as well, which they like too. And
mhm,
they're also interested in becoming more sustainable. So it's a win-win.
yeah. And sustainability is the way that we really need to go because when you showed the case studies, and I was very impressed with the fact that there is a very I wanna say it's an old oil, but I know when we're talking about oils, we don't really say that. We can't say, oh, we have such an old oil in our system, but we say we have a healthy oil in our system that
Yeah,
has, stood the test of time, 18 years. That is really unheard of, especially in that application. So that is tremendous in terms of being able to still protect the system, have a
absolutely.
proper reliability, don't have all of those temperatures going crazy because I know how these turbines go. So that was
Mhm.
very impressive for me on my side. So that was one of the things that I'm like, wow,
Yeah,
mind
I like what
blown.
you said. Also, yeah, exactly. That's also for the customer. They are so surprised because it goes against what they have been taught and what they have been
Yeah.
practicing for so many years. So we're a little bit fighting a stigma there as well. But I like what you said in going from, oh, this is an old oil, so I must change it, to looking at the actual condition of the oil, right? Because how do you determine whether you have to change your oil? It's not just about the time it's been in the system. There are so many oil analysis tests like the ruler and MPC, particle counts, but also ICP, FTIR. There are so many ways that we can look into the actual condition of the oil and determine whether this oil is old or not, so to speak. And we can actually determine how much life is left in the oil. So that's something we have to look at. We should not look at how long has the oil been in the system. We should look at how long does this oil still have to go? How long can I use it? And how can I,
Yes.
what actions can I take to keep on using it, right? I think that's a bit of a change
Yes, and I
in
think, yeah,
sorry.
definitely, because I know we talked about it in the presentation that you just gave in
Hmm.
terms of the additives being depleted over time. And
Hmm.
that is something that we see time and time again, and especially within our industry, coming up to turnaround sessions, we have people
Hmm.
talking about, I don't know if to change the oil, if to not change the oil, if they're seeing the antioxidant levels drop down too low, if they're seeing
Hmm.
the MPC levels get a bit too high, and then they're seeing all of this temperature fluctuations as well.
Hmm.
And I saw it in the case study that you shared with the offshore drilling company.
Hmm. Hmm.
Nobody wants to stop. Nobody wants to stop production to say, okay, well, I'm gonna do this flush, I'm gonna change out all of the oil, I'm gonna do all of this, because that is a lot of time and a lot of effort
Absolutely.
to get that schedule in terms of logistics and all of these not so great things when you're handling those sort of things. And
Abs-
that it's expensive. It's
It's
not it's
expensive.
not cheap.
Yeah, definitely in the offshore industry, because a shutdown there is
Hmm.
directly related to a loss in
Yes.
revenue, right? So
Oh my
yeah, that
gosh.
if they have to shut down a power generation turbine, especially if it's unexpected, because then they also don't have
Yes.
they don't have the redundancy and they don't have the equipment on in stock there basically to immediately do something with it. So they run into a couple of weeks of delay, and that means weeks of not producing. And you know how much that costs when you're pumping up oil. That's enormous. You're talking hundreds of thousands a day
Yeah.
that they can lose. Yeah.
Yeah, and that's not something anybody wants to do or
Exactly.
anybody wants to experience.
Yeah.
So I'm very grateful that there is a solution out there that people can use, that people can utilize and try to be a little bit more sustainable,
Exactly.
because I
Yeah.
saw the I saw the different emissions that were saved, especially
Hmm.
for that last power company, the first case study that you did with the
Hmm.
power company, and being able to save that amount of CO2 emissions,
Yeah.
like that is mind blowing as well.
Yeah.
Because a lot of times, especially within our industry, we do not come across areas where people are able to save, especially in that CO2 area. So I'm glad
Mm.
that we have that option, and we are always moving towards a more environmentally sustainable, environmentally friendly, different sort of we want to move the industry within that realm,
Mm.
because I know it's a lot going in that way, but we
Yeah.
all have to do our part. So I'm glad that you brought that up for us.
Thank you. Thank you. I think what's also very important there is that these carbon savings that we show, they are validated. So nowadays there's a lot of methods. Everybody has life cycle assessment methods, and the governing bodies, the
Hmm.
industry bodies such as API or ICML or the European, the American, and the Asian industry bodies, they're all kind of coming together to make one coherent method of looking at life cycle assessment. How does a lubricant pollute, and how can we put a measure on that? How can we put a value on that? So that also makes it easier nowadays to really determine via certified method how much CO2 are you saving by applying this method. So that's relatively new, right? So nowadays we have as the end user the option
Hmm.
to really calculate in a certified way. So it's not greenwashing, not just plucked out of the sky. It's a real certified method to show, hey, I am decreasing my CO2 output by this much. I think that's something that you know is a good thing for users to look at and something new that they can play with.
Definitely. And it's something that we did not have in the past decade or the past century. Because
Exactly.
this was not like we are evolving all the
Yeah.
time. All the time we're evolving. And being able to track that and have a particular, I want to say, standard
Hmm.
in terms of determining that level, that helps us globally as a community
Yeah.
when we're trying to understand what sort of an impact we're making. Because the way that I calculate something may be different from the way that you do it. But if we have a full standard involved, then everybody's on the same page. Everybody knows how you actually calculate that. So I'm glad that you brought that up as well.
Yeah.
So we do not have any questions because I guess you did a really good job at explaining the Fill for Life. So what we're gonna do is that we're gonna close it off here for today,
All right.
tonight on my side, but today for you. And any other questions, you all can reach out to Lars. Yeah, some contact information there on the screen, or you can
Mm.
reach him on LinkedIn as well. You know,
Absolutely.
always active there. So thank you all so much for your time tonight, today,
Mhm.
and we will be seeing you all again soon.
Thank
Bye.
you very much, everybody. Thanks, Aya.
Bye.
Bye.